Hello and welcome. My name is Base, and today I'm gonna blind solve a UK syllabus paper. Now this time it will be the 2024. Now let me tell you up front, I have never seen the paper before, so I might be making mistakes along the way. So if I do realize that I made a mistake, I'll tell you my thought process of how I find or spot my mistake. But if I actually authentically make mistakes, then I'll annotate the video to tell you that I am making a mistake. So I'll be timing myself as well. As you can see, there is a timer on the bottom left. I'm going to spend time under 2 hours, and when the time is up, I'm going to be marking the papers. And let's see how that goes. Are you ready? Let's get started. I'll just hit the timer now. So the timer is hit. Let's get on with it. So we're going to start from statistics, yeah? Okay, question 1. Xian rolls a fair die 10 times. The random variable x represents the number of times the die lands on the 6. Using a suitable distribution for x, find that. Alright, so we know that it's a fair die. So a fair die has 6 numbers, 1 to 6. Each of them has the probability of 1 over 6, right? That's a discrete uniform distribution. So, but the probability of landing on a 6 is just 1 over 6. So this is binomial because you have a probability of success, i.e. landing on a 6, and not landing on a 6, which is 5 over 6, the rest. So for the first question, I'm going to write here. Okay, so hang on. This is stats. And number 1, part A. So we're going to be doing x modeled as binomial, and that is just 10 times. Each probability of success is 1 over 6, like that. Okay, so we're going to first find in question I, p of x equals 3. And this is done by using the binomial coefficient 10c3 times the probability of success to the power of x times the probability of failure to the power of the remaining, which is 10 minus 3, which is 7. And we're going to just use a calculator to calculate that, yeah? So it is 10c3 times 1 over 6 to the power of 3, and then times 5 over 6 to the power of 7. I'm checking if I put everything correctly, guys. Okay, so I'm happy with that. So I'm just going to write down the answer. And it doesn't say anything about significant figures, so I'm just going to do like that first. Good practice. And let's do 3 significant figures. I mean, you don't have to write this, but, you know, it's quite traditional to do that. All right. Now, another one, we need to find the probability of x less than 3. Now, you got to be careful, because if you're not careful, you will forget that this is a discrete distribution. That means you can't just plug 3 in the formula, or if you look at the formula sheet, you can't just use 3 here. You have to use px of less than equal to. And I'll show you, actually in the formula booklet, it says that the sign has to be less than or equal. And because this is discrete, less than 3 means less than or equal to, right? So we need to do that. And, okay, so, I mean, if we try look at the formula sheet, let me bring up the formula sheet. Yeah, let's see the formula sheet. So if we look at the formula sheet, we will have the binomial table, which is this guy here. Yeah, as you can see, it's x less than equal x here. Well, you don't have the exact probability of 1 over 6, right? You just have some nice numbers, 0.05, 0.10, and so on. So you don't have that. Now, for full transparency, my calculator here cannot do binomial properly. But if you have a proper calculator, the, what is it called, the EF model or something, it's not Casio, I guess. It's, yeah, you know what I'm talking about. You should know that the calculator, the right one, can do binomial distribution, like binomial CD or something. And then you can just put exactly the parameters in here, which is the number of trials and the probability. And if you put 2, in there, it's going to give you this probability. But what I'm going to do here instead, because you can also calculate it like p of x equals 0 plus p of x equals 1 plus p of x equals 2. Just going to have to go through some pain there because I'm not prepared with the calculator, so I take my responsibility to do that. Okay, so it's just 10c0 times 1 over 6 to the power of 0. I'm just plugging in the formula here, yeah? If you can bear with me, just enjoy watching me doing this, but otherwise you can just skip to the next part. This is 1, 5 over 6, 9 plus 10 to 1 over 6 to the power of 2, 5 over 6 to the power of 8. If we plug everything in there, we're going to get the answer. So I'm just going to do one by one. Not one by one, just... Well, we know that 10c0 is actually 1. 1 over 6 to the power of 0 is also 1. So I'm just going to do for the first term only. 5 over 6 to the power of 10 plus 10c1 we also know is 10, so 10 times, that's the second term there. And then again 1 over 6, whoops, it's not 1 over 6, 1 over 6 to the power of 1, which is just that. And then 5 over 6 to the power of 9. And then plus 10c2 times 1 over 6 to the power of 2, and then times 5 over 6 to the power of 8. Let me just check back everything again from the start. I'm happy with that. 10, 1 over 6, 1 and 9, 2 and 8, 10c2. Yep, okay. So that's all 0.77522 blah blah blah. Just going to round that to 3 significant figures. Alright, so that's the answer for this. Yeah, and that's part A done. Sorry, yeah, part A. Now part B. CN repeats the experiment each day for 60 days and records the number of days when x equals 3. Okay, find the probability that there were at least 12 days when x equals 3. Okay, so this is now taking the probability of success being x equals 3, right? But doing another binomial distribution where the number of trials is now 60 days. So it's like a follow-through, you know, a follow-through probability event here where you take the previous event and particular sub-event in the event. So you are rolling a die 10 times and you are interested in, on each day, how many times you're going to get 3, right? And then you are taking that to do 60 days. So I'm just saying that this is now, I'm just going to model as y, binomial again, 60 days. And on each day, so he records the number of days when x equals 3, right? So he just rolled the dice once a day and then records the number of days. Now each day, right, the probability of getting x equals 3, like i.e. landing on 6 3 times on each day, is the probability from the previous question, which is 0.15504. So you see, the reason why I keep this so that we can, you know, use that precise figure. Because if we use this, then if we want the final answer to be 3 significant figures, it might not be reliable. So we need to use something like, you know, 15504 or 05 actually. I'm just going to use 15505 here. Right? Just to round it to 5 significant figures there. All right? 15505. Okay, so that is the new binomial here. Okay? And now we want to find the probability that there were at least 12 days. So that is P of Y at least 12 days, like that. Yeah, at least 12 days. And that is just, let's see. I might be in trouble here because if I have to do 12 trials, so this is equal to just 1 minus, yeah? P of Y less than 11, less than equal 11. Okay, so I think I need a calculator for this, right? Because there's no way, the table doesn't help in the formula sheet. Okay, I have a contingency plan, so I'm going to use Desmos. I guess you can also use a calculator to do this, so you can just use a calculator, plugging in parameter 60 for the number of trials, probability of this, and 11 for the x, and you will get the cumulative probability. So this is binomial CD. If you look at the function in your calculator, you should see that. But I'm going to use Desmos. So guys, let me just try that. So I'm going to have to, yes, I have this open. So if you look at the website, you go to the website, there is an open graphing calculator. I'm going to go into that. So I'm not sure if it can do it, but let me just try do function here and go to statistics. I believe there is okay, is there a binomial? Spearman. Let's go down here, distribution, probability distribution. Aha, binomial distribution. Okay, here we go. We might be lucky here. And then if we tap down here, is there any more? Okay, so we're gonna do cumulative probability here. And yes, so just to make it fair, right? I'm just gonna try to mimic the calculator here. So I'm just gonna put this as 11. Yeah, and then the binomial here, you should put trials would be 60, and then comma, what? Comma. And the probability is 0.15505. Okay, so you should get in the calculator too to be 0.788. Yeah, let me just look at the more precise figure there. So this thing, yeah, is 0.78816. All right, and I'm just gonna use a calculator to, now I got the value, just gonna use a calculator to do a 1 minus there. There you go. So the 3 significant figure, I answer this. Yeah, that would be it. That would be the answer there. Let me actually look at what I did in the Desmos again. So I did a left tail. The trial is 60 and the probability of success is 0.15505. Okay, so I'm happy with that, I think. Okay, here we go. You can do that too if you don't have a graphing calculator yet. Alright, so that's done for B. Part C. Find an estimate for the total number of sixes that Xian will roll during these 60 days. An estimate for the total number of sixes. Okay, so that is basically asking you an expected number. That is just an expected number for this distribution, 60 days. Oh wait, hang on. Find an estimate for the total number of sixes. If we find the expected value of this distribution here, that is the number of days. Yeah, that would be the number of days when x equals 3. So what happens when x equals 3 is just the number of times, because the x probability is when the event x is when he rolls 10 times and how many sixes he got. So if we find the expected value of y here, which is, we're just going to take 60 times 0.15505. Okay, let's calculate that first. So we get 9.303. I'm just going to carry that first. Okay? Okay. Now that is the number of an expected number of times that x equals 3. But for each of the x equals 3, there are 3 6s. Yeah? So we need to multiply this by 3, because each of the days on the event y, x equals 3, which means there are 3 6s, because they're asking for number of 6s, not number of days. So you got to be careful. All right, so if we multiply that by 3, we get 27.909. Well, total number of times, I'm just going to do 28 here. Yeah, so that's 28 times 28 6s, the 2 significant figures, just like that. Okay, use normal approximation to estimate the probability that CN rolls a total more than 95 6s during these 60 days. Okay, so 95 6s, right? Okay. We know that the expected number of 6s would be about 27.909. Well, just in case, I think I should also write, you know, like 3 significant figures as well, like 27.9 here, 6s, just in case. And I'm going to be probably using this figure here. All right. Now, this is normal approximation. So from binomial 60 days. So, right. So in 60 days, hang on. Okay, that's fine, I guess. Yeah, I mean, from binomial, okay, it's a binomial. On the 60 days, you roll 600 times, because for each day you roll 10 times, right? So it's a binomial 600 trials. Yeah, I think that's fine. Yeah, because we multiply that by, hang on, 600. For estimate for total number 6 you roll. Wait, I think I think I got a wrong answer for C. I think we should look at this from the beginning. So if he rolls for 60 days, each day he rolls 10 times, can't we just do 600 trials multiplied by probability of 1/6? Yeah, I think I'm going to change my mind on this one. Sorry. Yeah, I think I'm going to change my mind on this one. So it's 60 times 10, right? Because it's like 3 that counts. So it can be 1 on the first day and maybe 20 on the second day. And overall, if we want the total number of 6s, we can just do 600 times in total, and then times the probability of each roll, right, which is 1/6. So that should just be 100 instead, I think. Much simpler, don't you think? Yeah. So that happens, guys. That's why I do a blind solve here, and I hope I annotated the video for you to warn you that, okay, alert, I'm going to make a mistake here, which I hope this will be fine. Okay, so D, now use normal approximation. Yeah, so we have 600 trials, and each of the probability is that. We're going to approximate this by normal. So the, okay, so the expected, so the mean, right, the mean of the normal distribution would be just 100. Okay, and the yeah, so it's mean equals NP, and the standard deviation, or the variance actually, is NP times N minus P. This formula is in the formula sheet, right? Oh, I forgot to open this. Okay, the formula is in the formula sheet here. Is NP times N minus P. So I'm just going to do 100 times 1 minus P, which is 1 minus 1 over 6, which is 5 over 6. So that's 83.33, blah, blah, blah. And if we square root that whole lot, we're going to get 9.1287. Okay. Okay, like that. Yeah, so that's my normal approximation. Now, we want the probability that he rolls a total of more than 96. So we want P of X. I'm just going to write Y here. Y of more than 95. Sorry, not 96. So this is P of Y greater than 96, greater than or equal. So when you do normal approximation, you got to make it greater than equal or less than equal first, right? So there you go. We're going to calculate the right tail, and I think you can use a calculator to calculate using normal CD, right, and doing the right tail. So I'm going to do that using Desmos, I guess. Okay, now, but first thing first, you need to apply the continuity correction. The mean is about 100, right, around here. But you are calculating from 96 to the right. So that is around here, I guess. Now, the continuity correction will have to be applied so that you account for the 0.5, difference in X there. So if you don't apply continuity, you will get this area, right? If you do greater than or equal. But when you do apply the continuity, you got to move a little bit so that the area gets a little bigger. And that's just the concept I go with this. Continuity, when it's applied, you will have slightly bigger area. That is just the concept. I don't remember anything else but just that about continuity correction. So because if you don't apply, you have this area. But if you do apply, you're going to go slightly to the left to make the area in the bell curve a little bigger. So that would be 95.5 instead. Yeah? So you got to have 95.5 instead for the continuity correction here. Yeah? All right. Now I'm going to delete this first. Okay. So we're going to calculate that using a calculator because we got everything into place here. I'm just going to do Desmos. And this will be another function, normal distribution. So we go to statistical distribution here, normal dist. And if I do a mean of, what is the mean? 100 and comma, and standard deviation. Note that you need to put standard deviation down. So I'm going to put 9.1287. Yeah. And cumulative probability. Okay, so we go to the right. So I'm just going to put right here. Yeah, that's X greater than. So our case would be 95.5. That's it. So that makes sense because if you saw the bell curve I drew just now, it's slightly to the left of the mean. So the area should be bigger than 0.5. And we get that. So this is 0. Let's have a look at that. 6, 8, 8, 9, 7, 6, blah, blah, blah. I'm just going to round that again. 3 significant figure. Yeah? Like that. Okay, so that's the approximation there. Yep, more than 95. Okay, there you go. So that's just the first question done. Oh my God, I spent 23 minutes already. All right, I need to hurry up. Okay, question 2. Question 2, am I studying the flight of a bird from its nest he measures the burst height above the ground h and at time t for 10 values of t. I'm going to find the equation for the regression line for the data to be that. Interpret the gradient of this line. Okay, so the gradient of the regression line equation is the one, so you have the gradient to be b equals minus 1.28 here. That's the gradient there. It's just in front of the t. Okay, so the way we interpret the gradient is we say that for the change in x, the y changes by this. But we need to put in the context. Otherwise we won't get the marks. So for every, so what is the t? For every 1 unit, for every 1 second increase in time, right? Let's see. The flight of bird. Okay. For every second increase in the, so t is the time of flight, right? This is talking about the bird's flight time. Okay. Yeah, that's increase. The height above the ground decreases, yeah, by 1.28 meters. Just that. Make sure you put the right units and the right context in. Sometimes they do, you know, like thousands and millions and so on. So you got to be careful there. Now part B. The product moment correlation coefficient between h and t is minus 0.510. B, test whether or not there is evidence of negative correlation between the height above the ground and the time during the flight. Okay, state your hypotheses clearly. Use 5% level of significance. Okay, so significance level equals 0.05, and the number of samples here is 10, right? So n equals 10. We're gonna find the critical value. Okay, so the critical value, so let's look at the table. Okay, so we go to the product moment correlation coefficient table. Yeah, so this one, critical values for correlation coefficients. So if we look for the sample size of 10, which is this, yeah, this line here, and the level of significance of 5, which is this, right? This is 5 right here. So that is the critical value of product PMCC. So the critical value is 0.5494. Just note down the value first. Let me make sure this is not two-tailed because a negative correlation. Yeah. So the critical value is then minus that. This is the crit value. Because you got to realize that by yourself, that if you do a negative correlation, you got to put a minus sign into that, right? Okay, let me just go back to the, let me just check again. Yeah, 0.05, yeah, we are good with that. Okay. So we're going to test whether or not there is evidence. Okay, now because the PMCC of this is minus 510, minus 0.510, sorry. And that is greater than the critical value, right? So to reject null hypothesis, you need to be in the critical region. So to be in the critical region, if we talk about both types of correlation, positive and negative, the critical region for this particular critical value would be, you got to be PMCC less than this value or greater than the positive value. You got to be greater than or less than to suggest any strong evidence that there is a good correlation in the data there. Yeah, I mean, to make it kind of like critical and evident enough, you need to do better than the critical value, basically. And to do better than the critical value, you have to have a better magnitude of PMCC. And that is to suggest that, okay, I have already done better, because if I have a more a greater number than, let's say for the positive side, if you have a greater number than 0.5494, then you have done better. So you're at critical region. And because this is not better, this is greater than the, the critical value there. So you are doing worse, because your PMCC is kind of like suggesting a weaker correlation, if you know what I mean. So this is where we accept the H naught. Oh, I forgot to state the hypothesis here. So H naught is R, right? We are using R. Yeah. Oh, we use rho. It's rho. Okay, rho equals 0, and H1 rho less than 0. Okay, that's just the negative correlation there. Now this one, we reject H naught, except H naught, because there is not enough evidence, yeah, of a negative correlation between the height and the time. That's it. Okay? So it's not fairly negatively correlated. That's what it's saying there. Okay, now let's do C. C, with the reference to scatter diagram, state giving a reason whether or not the regression line H equals that is an appropriate model for these data. Well, look guys, to me it doesn't look like a straight line, don't you think? I mean, if you draw a line of best fit there, really a poor correlation there. I mean, we already calculated the PMCC. We know the PMCC is just 0.5, so it is a weak negative correlation here. Yeah. So PMCC is about minus 0.510. So this is a weak negative correlation. Okay, as it is not close to -1. So therefore, the regression line H equals 38.6 minus 1.28 t is not appropriate. That's it. That's what I would say. Okay, with the reasons there. Jane suggests an improved model using, okay, so this is already hinting you that, yeah, it wasn't appropriate then. Using the variable u equals t minus k squared, where k is a constant, she obtains the equation. She obtains the equation h equals 38.1 instead, minus 0.78u. Okay, choose a suitable value for k to write Jane's improved model for h in terms of t only. Right. Okay, so interesting. It's like coding here. U is a new variable, right? We didn't see u before, now u comes. But u is like a t minus k squared. So, I mean, interesting. Interesting. Okay, so if we plug the whole, I mean, I'm gonna try this first. So that is the equation, and because u is the whole lot of t minus k squared, so it's like that. Now, if we look at the relationship that is given in the scatter diagram, yeah, it kind of looks like a parabola curve, right? You see? It has a maximum of 40 here. So we can take that. So let's say we assume that the maximum is 40 here. That's what I think. The maximum is 40 when t equals what? So this is about t equals 3.5, I guess, right? So maximum h when t equals 3.5. Just from the graph there, can you see that? If we put 3 equals 3.5, it's going to give you a maximum. So maximum is 40 equals 38.1 minus, I'm just going to plug everything in like that. Ooh. Right? And actually, you know, you can see that it is, okay, hang on. That's interesting. I mean, if it were to be maximum, then, okay, that is suggesting 40 is not a possible maximum from the model, because if you have a parabola here, the maximum should only be this value. So actually, 38.1 is the kind of like the modeled maximum, because that point right there might just be a little off from the trend. Okay, so look, I'm just gonna maybe change this and say that you know, k is just 3.5. So if you make if you assume that the maximum is around here, yeah, we can say that it's about 3.5. But the fact that the actual maximum from the model is not 40, because 40 is from the scatter. So when you draw the actual parabolic curve, it might be a little lower than 40. So we're going to take that. All right. So my take is just k is 3.5 right there. And we're going to substitute the whole thing in. Right? Choose the suitable value of k, write Jane's improved model for h in terms of t only. Okay, so h equals 38.1 t minus 3.5 squared. I think that's already done, or, I mean, do we need to expand that? Maybe not. It's just, yeah, I think this is fine. I don't think we need to expand. Yeah, so I'm gonna go with that. Yeah, I'm gonna take my chances. All right, guys, number 3. I need to hurry up, right? Mings is studying the large data set for Perth. I'm no expert on large data set. Okay, I'm just new to this. He intended to use all the data available to find a summary of statistics for the daily mean air temperature. Unfortunately, Ming selected an incorrect variable on the spreadsheet. This incorrect variable gave a mean of 5.3 and a standard deviation of that. Using your knowledge of large data set, suggest which variable Ming selected. Okay, look, I'm just gonna guess here, honestly, because I'm no expert on this. Because it says Ming selected an incorrect variable, right? Using your knowledge of large data set. So the mean air temperature is in degrees Celsius. Daily mean temperature. I think I'm gonna go with, I don't know, maybe daily maximum temperature, right? Okay, I'm gonna go with that. Oh, hang on, the incorrect value, right? That is 5. It's pretty low, isn't it? So if you think about the, okay, in Perth, right? Perth is probably down to the south, if I'm not mistaken. I'm not in the UK right now, so I'm not familiar with the locations. I used to be. I think 5 here is too low for the average mean air temperature. The average mean air temperature in the UK should be kind of like 10. Yeah? Right? In the winter, it's probably less than 5. In the summer, it's kind of like barely 20. So it should be 10. I think 5 here is the minimum air temperature, the daily minimum. Yeah, I'm gonna go with that. air temperature in degrees Celsius. Okay, because it looks low, so I'm gonna go with that. All right, maybe Ming didn't realize that he got the wrong value, so yeah, I'm gonna go with that. Okay, part B. The correct values for daily mean air temperature would be summarized as that. Used to calculate the mean and standard deviation. So we will see what is the actual mean. Yeah. So mean x bar would be that sigma x, which is 2801.2 divided by 184. So I'm just going to bring back my calculator here. So, 2801.2 divided by 184. So that is 15. See? Okay, I was kind of right. So I'm just going to go with 15.2 maybe degree Celsius. Don't forget the units. And then the standard deviation, right, would be just square root of sigma x squared over n minus x bar squared. So that is the square root of variance, right? Yeah, I'm just checking the formula. Actually, you know what? See if I have formula sheet. If I have anything in the formula sheet here, just to tell me if I got the right value. But I think it is. Just checking for sure. Yeah, I think that's fine. Hang on. Expected value. Yeah, that's kind of it. Yeah, I think it is. Oops. Okay, so I'm gonna just do that math. Square root of 44695.4 divided by n, which is 184, minus the mean that we already got. So I'm gonna carry some more numbers here. Okay, so that will be, we're gonna put that as answer. Then square root of fraction of 44695.4 divided by 184. Just checking the numbers. Minus answer squared. That gives me 3.338. Blah, blah, blah. So that's 3.3334 actually. Alrighty. Okay, so that is the mean and standard deviations. As you can see, it's not that low. Okay, part C. One of the months from the large dataset for Perth in 2015 has a mean of that. Okay, that is kind of summer to me, or spring maybe. Standard deviation sigma x is that. For the daily mean air temperature, suggests giving a reason a month these data may have come from. You see, yeah. So Perth, presumably in the south, if I'm not mistaken, sorry if I am, would have, let's see, it's going to be warm, right? It's going to be kind of warm. So 19 here, I would say it's not going to be spring yet because it's already warm, maybe towards like just after summer. So this could have come from after summer. So after summer is autumn, right? So I think this might be, like October. No, that's getting cold, right? Is it June? Hang on, June, July, August. I'm gonna go with September, maybe. Okay, because Perth in the south is warmer in autumn. That's just my understanding there. And the typical summer temperature in the UK is probably somewhere close to 20, right? 22, 23. Sometimes it could get to, I don't know, 25. When I was there, it was 25 once, and they call that Indian summer or something. All right. Yeah, so I said September there. I could be wrong. Let's see if I am right. Okay. Next question, question 4. The proportion of left-handed adults in the country is 10%. Freya believes that the proportion of left-handed adults under the age 25 in this country is different from 10%. She takes a random sample, 40 adults under the age 25 in this country, investigate her belief. So A, find a critical region for a suitable test to assess Freya's belief. You should state your hypothesis. Okay, so hypothesis here is the p-value. Oh, it's actually the mean. Is mean 10%? 10% is 0.1. And alternative hypothesis would be, so she believes that it is different from 10%, so mean not equal 0.1. Significant levels is 10%, but we are doing two-tailed hypothesis testing here. Now, X is modeled, X is the population, is modeled as normal distribution, mean is 0.1, and the, okay, hang on, is this normal distribution? Yeah. She find a critical value for suitable tests. Because there is no there is no standard deviation here, so we probably have to use binomial. How is that even possible? Hang on. Okay. Yeah, probably binomial here, guys. Okay, I'm gonna go with binomial instead because we don't have because this is kind of discrete, right? It's either left-handed or not left-handed, right? So this is p equals 0.1 instead, and p not equal 0.1, and this will be x binomial, which is now the number of trials to be 40 and 0.1. All right. Okay. Yeah. So 5% level of significance. Yeah. Sorry, I said level of significance was 10, so it should be 5 because they take the 10% is the probability of being left-handed. Okay. So we're gonna calculate the probability of. So if we choose one tail, we're gonna calculate the probability of the sample there, which is oh, we find a critical region. Sorry. Okay, crit region. All right, crit region. So the way we find a crit region is to do, we are finding p of x less than x1. This is the left tail. It should be less than 0.025 because that's the probability of one tail. And also p of x greater than equal x2 should be also less than 0.025. So we are gonna find these two cases. If we go to the right, yeah, the critical value there, the area beyond that point would give you 0.025. If we go to the left, the area less than the area before the x1 should give you less than 0.025. And we can do that by looking at the table, right? It's easier. I hope there is a table there for this. So let's check the table together. So this is binomial. Yeah, binomial cumulative. So we have x less than or equal something. And now if we look at p to be 0.1, which is this column here, our n is 40. Yeah, we are off luck because n40 here is here. So n40, 0.1. So we're just going to write down something like this. So we have to write down. So px of less than equal 0, which is equal 0. is 0.0148. That is already less than 0.25. But we got to show that this is the first one that is in the critical region. So if we go to the next one, this is number 1 right here, right? X of less than equal 1 is 0.0805. And that is not critical anymore because it's more than the significant level of that tail. So we're going to choose that. And then, you know, we're going to do the same for the other one, but you got to convert this first. So we're going to do P of X less than or equal X2 minus 1. You got to go one lower when you go on the other tail. Yeah. And that has to be greater than 0.075. Sorry, 975. It's like you are flipping the side. Can you visualize that? You are flipping the side because this table doesn't give you X greater than equal X. So you got to do, so for example, if this is 10, this got to be 9, right? That's why I minus 1 there. So we're going to find something that gives you more than 975 first. Okay, I spotted that this one right here, I'm just going to write X less than equal 7 there, gives me 0.9581, and then the next one less than 8 equals, yeah, this one is already greater than what we want. There we go, right? This is 8 here, yeah? So that means, so x1 here equals 0. I'm just going to write that first. And then x2 down here is going to be, so if I write, this is the same case as that. It's critical there, right? So this is x2 minus 1 equals 8. So x2 has got to be 9. So you got to flip on the other side to be 9. When you see 8 is more than 0.975, which is 0.9845 here, you got to flip on the other side and it becomes 9 instead. Okay, so that means the critical region, just going to summarize here, is then x equals 0 or x greater than equal 9. Okay, so that would be the critical region there, just from the, you know, analysis from the binomial distribution there. Okay, now back to the paper. Now, if we want to write down the actual significance level from part A, right, we're going to have to add up. So the significance level, you can just choose, you know, like the tiny area after this one and the actual area of this one. So just going to highlight this one first. So it would be 0.0148 plus, you got to choose the right tail area. So that is not this because this is the left tail. You got to go to the right, which is 1 minus that, right? Yeah? So that is just, wait, hang on, 0. Okay, 0.1, no, 0.148 plus 1 minus 0.9845. That's 0.0303. Okay, here we go. Yep. Just checking. Okay, here we go. That's it. That's the answer. Okay, now part C. In Freya's sample, 7 adults were left-handed. With reference to your answer in part A, comment on Freya's belief. Okay. 7 is not in the critical region. Yeah? Is less than 9, so not. 7 not in crit region. Right? That means we do not reject now, we accept H naught. Right? So there is not enough. Wait, what does she believe again? She believes that it is different. So, but we found that it's not significant, so it's not different. There is no evidence, not enough evidence. to support that the proportion of left-handed adults under age 25 is different from 10%. So Freya believe not supported. That's it. Okay. Okay, let's go to the next one. I'm losing time here. Number 5, the records for a school athletics club show that the height h meters achieved by students in the high jump is normally distributed with a mean 14 meters and standard deviation of that. Okay. Find the proportion of these students achieving a height of more than 1.6 meters. We just find the probability there. So for part A, it's just x modeled as normal distribution of 1.4 as a mean and standard deviation of 0.15, but we need to write like that. And we want the probability of x more than, which is fine. Now, normal distribution doesn't care about greater than or equal, or only greater than or greater than equal, because it's continuous, except when you use it in normal approximation, right? Okay, so we're going to find this, and I remember that you guys can also do that in your graphing calculator, so that means I can use my Desmos, right? And what happens to the... Okay, here we go. So function, I'm going in normal distribution here. It's 1.4 for the mean and 0.15 for the standard deviation, and I want the probability of greater than, so let me just move it here. So I'm doing right tail of greater than 1.6. That is the answer there. So I'm just going to write 0.09121 blah blah blah. So that's 0.0912. The 3 significant figures. All right. Okay. B. The records also show that the time t seconds to run 1,500 meters is normally distributed with the mean of that and standard deviation of that. The school's head would like to use these distributions to estimate the proportion of students from the school athletics club who can jump higher than 1.6 meters and can run 1,500 meters in less than 5 minutes. Okay. State a necessary assumption about h and t for the head to calculate an estimation of this proportion. The assumption is that, well, if you want a very simple assumption, h and t should be independent. Like the person who jumps high doesn't mean that they will run fast or something, right? Otherwise, if they are dependent, i.e. not independent, then you're in trouble. So you need to find a correlation and whatnot, right? So h and t are independent. That's a very key there. Yeah, just going to go with that. Find the head's estimate for this proportion. Now we got to calculate. So the first thing is we have to calculate the person. Okay, so we need to find the y first. Y is it's about the running probability there, the mean of 330 seconds and standard deviation of 26. And we want the people who run less than 5 minutes. 5 minutes is 300 seconds. So we want P of y less than, right? Less than 300 seconds. We want the probability of that first. So we're going to use a calculator again. Now we just change it to 330 and 26, right? And then we want less than, so we go to the left. And that should be 300. So the answer is 0.12428. I'm just going to go with 1, 2, 4 like that. Yeah. Okay. Now, if we want to calculate the estimate for this proportion, that they jumps higher than 1.6 meters and also run less than 5 minutes, then we multiply. Yeah. So basically we just do p greater than 1.6 multiply py less than 300. Because they are independent. So when they're independent, you can multiply them like that, right? So this is 0.0912 times 0.120. Bring my calculator there. So 0.124 times 0.0912. Okay, so that's 0.011308 blah blah. So I'm just going to do 3 significant figures like that. I'm done with C. Let's do D. I think I can you know, get more time back when I do mechanics. And I hope this is the last. Oh, it's not even the last one yet. Okay, I'm doomed. Okay, so D. Students in the school athletics club also throw a discus. The random variable, the blah blah blah, represents distance meters that student can throw in discus. Given that p less than 16 equals that. Okay. So when we see it asks mu and sigma here for the normal distribution, you know that this is simultaneous equation. So you're going to set that first and solve them. Okay. So you need to calculate. You need to find the z values first. And we can do that in your calculator. You go to inverse normal, right? You go to inverse normal, but I have a function here that can do that. So this is, you got to calculate the probability knowing the z value. Sorry, you got to calculate the z value knowing the probability. Oh, hang on. Can I do that? Let's see if, I don't think I can do that in my calculator. I'm doomed. See if I have a table here. Aha. I have this percentage points of normal distribution here. See if I have, yeah, I have 0.3. Okay. And then I have 0.1. Oh, I'm lucky. Okay, I'm grateful. So we know that P of D greater than, okay, I'm just going to use a Z here. Z greater than, okay, 0.5244 is 0.3. Just from this table right here, guys. It's the right part. Therefore, we know that if it's the opposite, it's a minus Z, that is also the same value because normal is symmetrical. Yeah, make sure you understand this if you want to use a table like I do here. And okay, so that's our Z value there. And the other part is the one we get the probability to be 0.10. So 0.10 from the question, I look at this part right here. So I just write the same Z of greater than 1.0364 is, wait, what? No, it's not that, sorry. 1.2816 is equal to 0.10. And for this one, we're on the right wing, so we don't need to flip the sign there. Let's go back to the question. Okay, so we can say that now from this one, right? So from this one and this one. Okay, from the first one, we can say that the Z value, we're using, don't forget that there is an equation to link the Z value and the X value here. Yeah, so from the first one, the Z value has to be negative because it's on the left wing of the normal distribution. What is that number again? It's 244. Equals X, which is 16.3 minus mu. And I'm just going to do sigma right here already. Yeah, moving sigma to the other side if you don't mind. And for number 2, right, it's 0.1. So it's 1.2816. Sigma equals, and the data is 29.0 minus mu. So we got two simultaneous equations. Simplest way is to maybe subtract them. Yeah, subtract them like that. So we get here, just going to use a calculator. Because when we subtract them, we get sigma first. Yeah, minus 0.5244 and minus 1.2816. So when we subtract them, we get minus 1.806 equals, the mean goes away, and then we have what? 16.3 minus 29 minus 12.7. Oh, this is sigma as well, so I've got sigma here. So I have sigma to be minus 12.7 divided by minus 1.806, which is 7.03212. Okay, that is my sigma there. And if I plug it into one of the equations, I can find mu. So mu equals 29. I'm just going to go with the second one. Minus 1.2816 times 7 point that. Okay. So I'm just going to equal that first and then clear. And then 29 minus 1.2816 times answer. That is 19.9876 blah blah blah. So the mean is then 19.98. So if you do three significant figures, it should be 20.0, and then sigma is 7.03. All right, so that's it for me. Just simultaneous there for part D. Now we're done. Let's do the last question. I'm running out of time for mechanics. I hope mechanics only has 5 questions. Okay, the Venn diagram where P, Q, and R are possibilities showing the events A, B, and C, and D, associated probabilities in there. State any pair of mutually exclusive events. All right, so mutually exclusive, not intersecting, just A and any pair. Do we say 2 or 1? Just A and C. Yeah, it says any pair, not all pairs, so I'm just going to go with that, A and C, right? The events B and C are independent. Okay, so we know that independent, they multiply to get the intersected area. So PB times PC is PB intersect C. PB is, if you add up all the areas here, 0.5 plus 0.27 is 0.32. So 0.32 plus P times C, which is, this is 0.27, 0.08, 0.35 plus 0.25 is 0.6. That is 0.6 then, equals the intersected area 0.27. Here we go. So solving for P, we can just rearrange the equation. So 0.27 divided by 0.6 to undo it there. And then that would just be minus 0.32 to get the P as a subject. There you go. Part C. Find the greatest possible value of that. Okay, so P, this is conditional probability. So I'm just going to write out from the formula first. So it is A intersect B prime, yeah, for the top bit, and divided by PB prime. Okay, just plugging in everything. The greatest possible value. So, okay. So A intersect B prime is just Q, isn't it? Right? So this is Q. A intersect B prime, yeah. And then divided by B prime. So B prime is outside B. So that would be Q plus 0.35. Okay? And that is just the thing we need to consider. Now, it wants the greatest possible value. Okay. What is the maximum value of Q? We got to consider that. Now, you have Q and R, right? So I'm just going to write first Q plus R, which are still unknown, will be, all there is left for them. So Q and R added together, we're gonna have what? 1 minus the whole lot of the others, which is 0.05 plus 0.13, which is P, plus 0.27 plus 0.25 plus 0.08. That's Q and R, right? So I'm just going to use a calculator here. 0.05 plus 0.13 plus 0.27 plus 0.25 plus 0.08. That is 0.22, right? Yeah. So that is all that is left for Q plus R. So the maximum of Q here can then be that. If we assume that R is 0, then that is the maximum value of Q. And the minimum value of Q would be, I mean, just in case if we need it, is just 0. So Q can be nothing there. Now, if we want the greatest possible of this whole thing, because that's what the question wants, then we need to make, what do we need to do? Okay, it's just, I just try to plug in there, see which one is more, and then I'll go with that. All right, so, well, if we put 0 in, it disappears. So we need to put some number in there, right? Okay, so I think I'm going to go with this then. Yeah, so that's maximum, hang on, max PA slash B prime equals that. So that's fraction 0.22, 0.22 plus 0.35. 0.386 then, 366. Okay, given that PB slash A prime, this is part D, given that PB slash A prime is 0.5, so that is PB intersect A prime divided by PA prime is 0.5. Okay, so what is this? Let's look at the diagram again. PB intersect A prime is B intersect A prime is P plus 0.27 divided by A prime. A prime is just outside everything where you have a C, which is what again? Okay, 3.5. C is 0.6. Is 0.6 plus R plus P, right? Is that? Yeah. And this is telling you that it is 0.5. So because we already know P, so we're going to solve R there. So the top bit here is P is, I remember, 0.15, right? Yeah. So that's going to be 0.4 equals, this is 0.5 times 0.13 added to 0.6 is 0.73 plus R. So R will be, multiplying all out there is 0.4 minus 0.5 times 0.373 divided by 0.5. Okay, just solving the equation there. Okay, exactly 0.07. All right. So Q would be then, I remember that they added to 0.22, so I'm just going to take the liberty of doing that, 0.22 minus that, yeah? Minus 0. I don't know why I need a calculator for that. Maybe I'm a little excited here. Okay, so 0.15 here. Okay, next part E. I'm still not done with this. Find the probability of that. Okay, this is horrible now. Okay, A union B and prime. So this is outside A and B. Is just this bit of C here and R. And intersect C. So it's just this bit of C. That should be fine. So it's just 0.25 plus 0.08. Which is 0.33. Is that right? Union and then prime, so it's just outside and intersect with C, so it's just these two. Okay, F, use set notation to write an expression for the event with probability P. Well, that's like B and taking out A and C, right? So I'm just going to do P of B how about intersect A union B, A union C, A prime union C prime. I'm going to go with that. A prime union, wait, yeah. A prime union C prime is just everything outside, no, hang on. A prime intersect, hang on. Should be A prime intersect C prime. A prime intersect C prime is everything outside but not in A and B. Is that right? Yeah. Which is everything outside A and C, right? Everything outside A and C. But if you intersect that with the B, you get the middle part. Okay, I think I'm happy with that. That's it. Okay, guys, I'm done with this. So I need to change the paper now to be the mechanics, which is this guy right here. Okay, let's go, guys. I'm running out of time. How many questions? Just have to look first. Okay, 6 questions, guys. In 45 minutes. See if I can make it, right? I think I should. Mechanics. Question 1. Figure 1 shows a particle P of mass 0.5 kilograms at rest on the rough horizontal plane. Find the magnitude of normal reaction on the plane of P. So normal reaction is quite basic. Normal reaction is just mg because it's not pushing against anything at rest. So that is just 0.5 times 9.8. That's simple. I think it's 4.9 there. Okay, so that's Newton. And then that's part A done. Part B. The coefficient of friction between P and plane is 2/7. The horizontal force of magnitude x newtons is applied to P, given that P is now limiting equilibrium. So in limiting equilibrium, the friction will have to be equal to the pushing force, which is x. And friction is mu n, or mu r actually, but I wrote n there, which is the normal reaction, equals the x. We want to find the value of x, so x is just 2/7 times that. So 7 cut 4.9 is 0.7. 0.7 times 2 is 1.4 newtons. Oh, that's simple for the first one. Okay. Yeah. Number 2. Figure 2 shows a speed time graph for the model of the motion and an athlete running in 200 meters race in 24 seconds. Start from t equals 0, blah, 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 blah. Okay, using the model, A, find the acceleration of the athlete during the first 4 seconds of the race, stating the units of your answer. The first 4 seconds, that's acceleration. So, okay, A is just v minus u over t. And then the first 4 seconds, so he goes from 0 to 10, so 10 minus 0 divided by the time is 4. So that's 2.5. And stating the units. Aha, okay, now it says units. So 2.5 meters per second squared. Okay, that's for part A. Part B. Find the distance covered by the athlete during the first 18 seconds of the race. So we need to find the area under the graph from 0 to 18. I'm just doing the triangle. Wait, hang on. This is a trapezium, right? So I'm just doing 1/2 times the height, which is 10, times the sum of parallel sides, which are from this bit to this bit is 14. And from 0 to 18 is 18. So that's 32 in the brackets times 10 is 320. 320 divided by 2 is 160 meters units. Yep. Okay, that's fine by me. C. Find the value of u. So u. Okay, here. All right. Now let's get some more information. The deceleration constant rate from 18 to 24. Okay. Okay. Crossing the finishing line. Okay, so we are missing the key information here that all the distance traveled in the 24 seconds is 200. So that means if we have found the distance traveled from 0 to 18 already, then the distance from 18 to 24, yeah, would be 200 minus the one we found earlier, which is 160. Now we get 40. So 40 is just the area of this bit of, graph there. Okay, that is also a trapezium on the side, right? So it's 40 equals 1/2, the height being 6 here, and then the sum of parallel side being 10 plus u, right? It's on the side. So 2 cancel 3 there, so u equals then 40 over 3, just solving the algebra here, minus 10, right? Yeah. And that will be 10 over 3 if you do the math. So that's it for me. Okay. Next, it's quite okay here. So far so good. A particle P of mass m is held at rest at a point on the rough inclined plane as shown in figure 3. It is given that the plane is inclined to the horizontal at an angle alpha, where tan alpha is 5 over 12. Coefficient of friction between P and the plane is mu, where mu is less than. The particle P is released from rest and slides down the plane. Air resistance is modeled to be negligible using the model A. Find in terms of m and g the magnitude of normal reaction on the plane. Okay, so held at rest, right? So held at rest, we have a particle here, mg here, right? Okay, let me think a bit. And release from rest, right? Okay, yeah, that's fine. So normally we would have to resolve, if this is alpha, we would have to resolve the mg, and this is mg cos alpha. This will be mg sin alpha. You have to be familiar with this resolving because it happens all the time in an inclined plane. So the normal reaction on the plane on P would be normal reaction R then, yeah, this is R equals mg cos alpha. We also have friction upwards. Okay, so that is m in terms of m and g. So cos alpha, if tan alpha is 5 over 12, this is the trick I use. I don't need to find the angle alpha. I just do, it's given you that 5 over 12 is the tan, so that's 5 and 12 there. So by Pythagoras triangles, I know that this must be 13. Okay, so cos would then be 12 over 3. So this is 12 over 13, sorry, mg. That's it in terms of m and g. Okay, now for B. Show that as P slides down the plane, the acceleration of P down the plane is that. So we do sigma F equals ma. Now sigma F down the plane, you need to do down force minus the up force. So the down force is mg sine alpha minus the up force, which is the friction. And friction happens to be mu r, right? Yeah. Yeah, so mu and r is just 12 over 13 mg. We got that earlier. Equals m and then a. So we are still keeping the mu here because we don't know what it is yet, but we can cancel the m out. Okay, now again, sine alpha is 5 over 13, right? So we're going to plug that in, 5 over 13 g minus, what is this? 12 over 13 g mu equals a. And that's it. So a equals, if we take out the 1 over 13 g as a factor, we're going to get 5 minus 12 mu inside. That is as required. Okay, chop chop. Part C. State what would happen to P if it is released from rest, but mu greater than that. Interesting question. Mu greater than that means that the friction gets larger. If the friction gets, okay, let's try put mu equals, yeah, okay. So if mu is at critical, which is 5 over 12, the acceleration here, if we plug 5 over 12 in here, 5 over 12, that will cancel, that goes to 0, right? A is 0. If it's less than 5 over 12, then you have some acceleration, means that it goes down. But if mu is greater than that, then A is negative. Wait, hang on. But if mu greater than 5 over 12 or equal, A is less than or equal 0, indicating that the downward force is not enough to overcome friction. It's like the maximum friction is greater than the maximum friction is greater than the weight component down the plane. Therefore, P will remain at rest. Doesn't move down, basically. Okay, I'm happy with that, so let's move on. I'm at question 4 now. Look at that. All right, still have 35 minutes left. At time t greater than 1, the position vector of particle p is r meters, where all of that, and c is a constant. When t equals 4, the bearing of p from O is that. Okay, so O is the origin. Bearing of p is 135, so that is the angle there. That's the bearing. This is telling you the velocity vector. This is the direction of the velocity. It gives you the position vector, but you got to be careful, right? The bearing of p, the particle p turns to this bearing angle. That means the velocity vector should be heading towards that direction. Okay, so we need to do dr by dt first. All right. Okay, dr by dt is equal to, wait, hang on. Could I be wrong? Sorry. No. This is position vector. Sorry. Hang on. It would have to say motion or direction. Then I would have been right, but I think I'm wrong here. So I'm gonna stick with the position vector. So it's like P is here right now. Okay. So yeah. Now we know that if this is the bearing of P right now, then you see the x coordinate, let's say it is A, then y must be minus A, because this angle is 45 degrees. So whatever A is, it's got to be, the y has got to be minus A, because they are doing, this is the fourth quadrant, if you can imagine. Yeah? If this is A, this is minus A. That means if you divide the x and the y components of the position vector, you get minus 1. So we can do already that ct to the half divided by minus that equals minus 1. And we also know that t equals 4. Okay, so if we plug 4 in, that becomes 2. So that's 3 over 8. That's 16 equals minus 1. So c equals that cut that. So 8 cancel that is 2, 2 cancel that, so it's just 3 as required actually. All right, almost got it wrong there, guys. B, find the speed of p when t equals 4. Now the speed, we need to do differentiation, so dr by dt is the velocity vector. So we have, okay, so c is 3 now, we know that, right? So that's 3 times 1 over 2 t to the minus 1/2 there, if we differentiate that, and this is I component, minus 3 over 8 times 2 t j. Wrapping up, we get 3 over 2 t to the minus half I minus 3 over 4 t j. And then when t equals 4, v will be, so 4, if we plug 4 in, this thing will be what? 1 over square root t, so that's 1 over 2. So that's 3 over 4, right? Yeah. Minus, that's 3j, just plugging in there, okay? So the speed then is square root of that. Okay, so whatever that is, square root of 3 over 4 to the power of 2 plus 9. Okay, can we do that? Okay, so that's 3 root 17 over 4. I'm just going to do decimal 2 here. Okay, meter per second. That's the speed. Part C now. When t equals t, p is accelerating in the direction of that. Acceleration is just the derivative of velocity. So a is dv by dt equals differentiating v here from the vector there. So we get 3 over 2 times minus 1/2 times t to the power minus by 1 is just that. I minus 3 over 4 because t goes away. Okay, so we get minus 3 over 4 t to the power of minus 3/2 I minus 3 over 4j. That's acceleration there. And yeah, so we need to make this acceleration vector into that direction. That is to say that these two vectors are parallel. So when they are parallel, we can say that if we multiply like k to that, yeah, it's going to be equal to that vector there minus I minus 27j. Okay, so that is the definition of something into the same direction. So one is a multiple of another, right? So if we take the y component here, we can see that minus 3 over 4k equals minus 27. That's the y component there. Okay, so I'm finding k first. So k is equal to 3 can cancel minus 27 there, and we get 9, and then this is 36. Well, that means on the x component, 36 as the k times this would be equal to minus 1. We just take the magnitude of the component I there. Okay, so I'm solving this. I'm canceling the minus sign. This is cancelled to be 9. So t to the minus 3/2 equals 1 over 27. Just solving that, right? Okay, so what is this? If I do t, if I just do flipping the power there, so you want to get rid of this power on the left side. So if you power everything by minus 2 over 3, they will cancel, right? They will cancel. Because when you multiply the powers, that goes away. So it's just powering the other side by minus 2 over 3. And you will get the answer. So 1 over, wait, what? To the power of minus 2 over 3. So that is 9. Okay? So my answer is then t equals 9. 9 what? 9 seconds. Gotta be careful with units here. Okay? So I'm done with 4. Now let's go to number 5. Oh, a long question, right? Okay. I still have energy, guys. At the time t equals 0, a small stone is projected with a velocity 35. Okay, I see it. Okay, 10 alpha, 3 over 4 there. The stone is modeled as a particle p moving freely under gravity. Thanks for that. Stone hits the ground at point point A here. Figure 4 shows the path of p from O to A. The motion of p from O to A at time t seconds, the horizontal distance of p from O is x meters. Okay, and vertical, yeah, it's just saying xy there. So xy is like the coordinates of any point on the path here, basically. Using the model, show that, okay, here we go. So this is y in terms of x. More like a parabolic function there. Okay, so if we consider the initial speed, yeah, so ux is the initial speed along the x-axis is 35, cos alpha. Agree with me on that, right? And okay, we have this technique again where it's given you the 10 alpha and 3, 4 here, so we do 5 here, Pythagoras. So that means the cos alpha is just 35 times cos alpha, which is 4/5. So that's 28. So uy is 35 times sine alpha, which is 35 times 3/5, which is 21. Okay, meters per second, of course. Okay. Now, let's assume that at any point along that path, the time is t. Okay, at xy, time equals t. Yeah. So that means x will be equal to, now because along the x direction, there is no acceleration. So I can do speed times time. So I get ux times time, which is 21t. No, it's not. It's 35. No, 28. Sorry. Okay. So far, so good. And for the y, because the y has an acceleration, the y direction has an acceleration vertically, which is the gravity there, which is, we're going to take it as 9.8 then, right? Seems like, okay. There's no g here. It doesn't have any g, so yeah. Okay, we can stick with g. And then for the Suvat equation along the y direction, we need to use uyt plus half ayt squared. All right. So here we use uy to be 21 and maybe ay to be 9 minus 9.8. We got to be careful there. So 1/2 9.8. I already put the minus sign in front and t squared. Now if we plug in t in terms of x here from the horizontal axis, so we get x over 28, right? T in terms of x. We're going to put that in the t because we don't want t here, so that's why I do that. And that is x over 28 times x over 28. And hopefully that should simplify to that equation right there. Okay? So let's see. If I do 7 cancel here, I get 3/4x. Yeah, that looks good. And then this is a lot of canceling here, but I'm going to try use a calculator. So 9.8 divided by 2 times 28 times 28. It's 1/160 indeed. There you go. So as required. Part B. Use the answer to A or otherwise to find the length OA. Well, OA is just basically the path where it's like returns to the ground. That is when y equals 0 again, right? So we need to solve that quadratic equation, putting this whole thing equals 0, and solve that. So this is basically 0. If we factor x out, we get 3/4 minus 1/160x. So x equals 0 is trivial because that's the initial point. That's not important. So we need to do 3/4 divided by 1/160 here. And that is just 3/4 times 160, so that's 120 meters. Yep, I'm happy with that, I think. So that's 120 is the answer. Part C. Using the model, the greatest height of the stone above the ground is found to be h meters, using the answer to A again, or otherwise find the value of h. So this happens at a turning point right here. And if we think about that mathematically, we can just differentiate y respect to x and find the turning point, right? So I do dy by dx equals 0 equals, that's just 3/4 there. If you differentiate this guy right here, minus, so if you bring 2 down, it's going to be 1/80x. And then we just solve for x and then just plug that into the y and get the y, right? So this is, again, 3/4 divided by 1/80, which is 3/4 times 20. So, sorry, 3/4 times 80. So that's 3 times 20 is 60 meters, right? And y at 60 meters of x would be, what's the equation again? Yeah, 3 over 4 times 60 minus 1 over 160 times 60 squared. Need a calculator for that, maybe. Times 60 minus 1 over 160 times 60 squared. That is 22.5 meters. Okay, so that is the h. Okay, I'm done with part C. Part D now. The model is refined to include air resistance. Using this new model, wait, what? Hang on. The greatest height of the stone above the ground is found to be k meters. State which is greater, h or k, justifying your answer. Right. If you include air resistance, okay, let's look at the path here. If you include air resistance, right, you're not going to go as high, probably, because along the way you are losing energy. I'm talking about this physically now. This is a physics. Okay, so you lose energy along the way, so you're not going to go as high, right? You lose kinetic energy, so you're not going as high now. That means k will be smaller than h. All right, so k, which one is greater, is h then. All right, so there is energy loss along the trajectory, so less kinetic energy will convert to GPE. Therefore, height is smaller, k less than h. Okay? Yep. Part E. State one limitation of this refined model. Okay, so you include air resistance. Interesting. But the curve might not be parabolic. It might be like this. Yeah? Because, or hang on. Yeah, it's like when you have greater speed, the acceleration changes. So along the way, if speed changes, then acceleration changes, and it's not parabolic anymore, right? Physically speaking, yeah. So the path may not be parabolic when air resistance is considered. It's going to be a little weirder than parabolic, right? And if you do engineering, you can, experience that in dynamics of particle. Okay, number 6. I think it's the last one, and I got 18 minutes-ish, 17 actually. Figure 5 shows a uniform rod AB of mass M and length 2A. The rod has its end A on a rough horizontal ground. Rod rests in equilibrium against smooth horizontal peg P. The point C on the rod where AC is 1.5A, the point contact with the rod and the peg. The rod is at an angle theta to the ground where tan theta is. They give you tan theta almost in all questions, right? The rod lies in vertical plane perpendicular to the peg. Okay, the magnitude of normal reaction on the peg is S. Okay, so let's draw a schematic first. That's the peg P here. And we want to find the normal reaction, R, right here. Okay, so the ground is rough, so I'm guessing it should be a friction there and a normal reaction N here. And then you have a weight. This is uniform rod, so weight there of mass mg there. And this should be a, because the length of the rod is 2a, so halfway is a there. Okay, so we're just going to take moment at point A, right? So consider moment at point A in equilibrium. So we're just going to do clockwise equals anti-clockwise. So mg times A equals, no, A, you need to do the resolving. So tan theta is 4/3 here. So that's theta. And then that's 5 again. So this is mga, what is it? Cos theta, because you are doing this distance, yeah? I prefer to resolve the distance down to perpendicular to the mg. So I'm taking this distance, which is a cos theta, equals the force from R there, the moment from R, which is already perpendicular to the rod. So this is 1.5a. All right, so a cancel, cos is 3/5, so mg times 3/5 equals 1.5 r. So r equals, wait, hang on, it uses s, so I need to use s. So s equals, so if you move 1.5 down, you get 7.5. Wait, hang on. What? That's not right, is it? 1.5a. Is there any more forces here? 4, 3, 5. Is there anything wrong? Cos theta is 3/5. Yeah, that's right. Huh? Oh, hang on. 3 cancel this. Sorry. 1.5 cancel this as 2. Yeah, sorry. Okay. There you go. That's part A. As required. The coefficient of friction between the rod and the ground is mu. Given that the rod is in limiting equilibrium, that's the key word there, limiting equilibrium, find the value of mu. So limiting means that friction is at maximum. And n here, okay? Now, there is an n here, so we need to find n first and plug that into the other equation, which is the horizontal. So there is a angle here, so I think if we look at the diagram, this is also theta. So this is 90 minus theta, so that means this is also theta, okay? This is theta. Let me check that. Theta, 90 minus theta, yeah. So F will be equal to, well, if we do the force resolving here, this is going to be R sine theta, and this is R cos theta, right? Actually, it's S, not R. Right, yeah? So that's the only, okay, we can find the n, because the n is just, so if you do vertical equilibrium on the Fy here, we're going to have n plus S cos theta equals mg, right? And we already know S. I'm just going to add a page here. S is 2/5 mg, so n is just mg minus 2/5 mg, which is S, and then cos theta again, which is 3/5. So that fractions right there multiply to be 6/25. So that is 19/25 if you subtract them. Yeah, 25 minus 6 is 19. Yep, so that's 19/25 mg for the, oh, not the answer yet. And that is the friction. So if you do the Fx equilibrium, we get the friction to be equal to the sine theta from the normal reaction. So S sine theta is equal to the friction. So S is 2/5 mg again, times sine theta, which is 3/5, equals mu, we are finding it, n, which is just 19/25 mg. Mg cancel, 25 cancel, so we get mu to be 6/19. And that is just the answer. So I have 10 minutes left. I think I'm gonna call it at that, and let's mark the paper together. All right. Okay, here's the mark scheme for the stat part, 2024, of course. Let's mark the paper together. I have no idea how well I did. Maybe good, maybe bad, no idea. Let's have a look. Okay, nailed the distribution bit there. Blah, 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 award that. Okay, that's part 1. Part 2, 775, yeah, got it. Part B, 212, yeah. 100, yes. You see, I almost made a mistake on this. Yes, I realized. And then that should be fine. Ooh, okay. Wasn't so bad for number 1. It's like I spent 20 minutes on it. Okay. At least I got all the marks. Hang on, where's question 2? Okay, here. Okay, the height decreased by 1.28 for every second of flight. Yeah, got it. Part B, that. And then critical value is this. And then insufficient evidence. Okay. C. Yeah. Gradient is positive. The curve is quadratic. Since points are non-linear, but regression model is linear. Okay, what did I say? Weak negative correlation, as that is not close to -1. Okay, as you can see, yeah, so I didn't look at the scatter. I just used the correlation, the PMCC. So I got it wrong here, I would say. I got it wrong. So I should have looked at the shape of the correlation, and it's like a quadratic. So yeah, not close to 1. Okay, yeah. I'm not gonna give myself a mark here, -1. And then what should be that? Yeah, I got K in the range. Oh yeah, I got it. I think this one I got it. Okay, yeah. For number 3, rainfall. Okay, all right. There's no such a thing as daily minimum temperature. So maybe I just made that up. So it doesn't exist. Probably not. Okay. Yeah, rainfall 5 millimeters probably -1. And that's 15.2 and 3.34. Yep. Okay, so September in South is warmer. What is the month? Month is October. Yeah, I said September. I just 1 month short of the right answer. Could it have been September? Oh, actual mean for September is that. Oh, this score is 0. I was close, but I got the wrong reason anyway. Oh, but there is 2 marks here, right? Method mean is higher than average. Perth is in south, so warmer. Okay, I need to look at this one. Mean temperature is higher. It's warmer. Yeah, it is warmer. Right. Okay, I got that. I got method marks. So -1. Okay. Just by guessing that Perth was in the south and it closer to the sea, so it's a bit warmer there. Yeah. Southern hemisphere. There you go. Wait, it's not in the UK? Oh, sorry, it's in Australia. Oh man. Sorry about that, guys. Particularly the Brits there, okay, who are watching. Yeah, sorry. It's in Australia. There you go. All right. Number 4. That is right. 40. So 0 and greater than 9. I think I'm right because I remember that. Yeah. Okay, I got all the probabilities listed down, so that's all fine. Yeah, that's right. Provided 7 is not in the critical region, so not enough evidence. That's right. Number 5, 0.0912. Okay. Oh, okay, I'm right here. Yeah. Part D. What is part D? Oh, just calculating those. Yeah, I got it in the range. They accept that range. Okay. Number 6, A and C there, 0.13. Part C, what do we need? The greatest value of Q is that. Is it that high? Greatest value of Q is 0.22. Yeah. Q max. So that is, wait, what? Is it? Why is it 0.4? Okay. It should award something else. Yeah, 0.22 divided by 0.55. Oh man, I must have this must have been a wrong number, right? Hang on, let me check the question. Okay, let me check the question. Okay, where's the question? Here's the question, right? No, that's not. This one. Okay, let's check question 6. So Q plus, where's Q plus? Q plus R, that's B prime. So B prime is, oh, this is, oh, I made a mistake on adding these two. Yeah. It should be 0.25 plus 0.08, and that should be 0.33. Okay, yeah. Okay, that's fine. Right, back to the mark scheme. All right, I accept my mistake. So, but I got the method, just lost the accuracy mark there. Okay, wait, really? Yeah, do they allow slip? You see, I didn't show the adding of the Q and the R and everything. Wait, hang on, or did I? Oh, yeah, okay, yeah, I did that. Yeah, I think I get a method mark there. I just lost one accuracy here. I just flopped on adding the numbers, which shouldn't have happened. Okay, part D. Yeah, got it. Q and R. Part E, 3. Okay, did I get that? B intersect A. Yeah, that is the same, right? Yeah, that's the same. Yeah, I got it. Okay. Now, mechanics. All right. Oops. Mechanics, where's mechanics? Is that? Okay, this one. Let's mark the mechanics quickly. Mechanics should be all fine, I guess. Should be all fine. Okay, for number 1 it's right. For number 2, 10/4 there. Units needed, of course, I gave it. 160 for B, and that is, for C is, part C, 10/3, in it? Yeah. Number 3, 12/13 mg. That is as required. P wouldn't move, remain at rest. Yeah, same thing. Part 4, question 4. Yeah, C equals 3. The mark scheme is very detailed. Okay. B. Yeah, I got that. I think I remember seeing that. Yeah. T equals 9 down here. Nice. I think I'm gonna nail mechanics. Oh, nail mechanics. Yeah. Okay. OX. That's 120. Part C. 22.5. Okay. D. Okay. We'll slow the particle down. Okay. Let's have a look at the flexibility. Take away energy. Yes. I got it. There is energy loss. Okay. So K is less. Part E. Let's have a look at E. Inaccuracy of the G. Okay. Let's have a look. The wind or weather effect, spin of the stone, still modulus particle. The ground may not be horizontal, or other things. The size, the spin, the wind. Oh my God, I didn't mention anything close to this. So maybe I don't get. Okay, this is bad. But honestly, yeah, if you consider air resistance, it shouldn't be a parabolic. But maybe this is other factors. It's not about air resistance. Okay, it's just other factors. It's quite hard to get this right. I tried it in the other paper, and well, in the other paper, yeah, it was fine. But this one, no. Okay, -1 there. Should be all that. Number 6. Yeah, I nailed that. 19 over, wait, what? Part B. Oh, 9 over 7. I got it wrong. Okay, this is another one where I lost marks here. Probably resolve horizontally. This is the horizontal and the vertical here. mg r equals mg minus. Yeah, I got that. All methods. F equals mu r. Yeah, I got that. So I made some mistake here, which I don't know yet. It should have been 8 over 19. Probably this should have been 4. Is it? mg cos. Oh my God. Wait, hang on. No. 2 over 5 mg is right, so. Oh yeah, cos theta is 4 over 5. Oh no, cos theta is 3 over 5. Wait, what? Fy, let's look at Fy here. So if I take moment, no, I didn't take moment. I just took S, yeah, it's probably the Fy. This is cos mg minus. So n is right, n is 19 over 25. Oh, sine, this one should be 4. Maybe I rushed too much. Okay, that one should be 4. So I think I lost 1 accuracy mark there because I wrote this first. So that was right. Yeah, just 1 mark. Okay, and that was it. So how many marks in total did I lose? 1, 2 for mechanics, I guess. Yeah, 2 for mechanics. And 1, 2, 3, 4 for statistics. So I lost 4 marks for statistics and 2 for mechanics. Wait, hang on, that's another paper, sorry. Yeah, so I lost 6 marks in total. Let's have a look. 6 marks in total, but what's the score for the whole paper? That should be equal, right? So it's yeah, it's 100. So 6 marks in total. All of them will be 94 out of 100 for me, for this whole walkthrough. Okay, guys, that was it. If you haven't checked out my other videos for the pure math on the 9MA0 /2 and 1 and 2, sorry, then please do. And if you haven't done so, please subscribe the channel, and I'll make sure that I keep walking through more papers to come. For those of you who still might benefit from my channel, then yeah, you should subscribe if you haven't done. And I'll see you in the next one. Bye.